everyone. This is our second talk of the day today. TimbreSpace, spatial storytelling through interactive soundscapes. Sound in XR is exciting and intriguing. And what they are going to be presenting today is an XR music sandbox where users sculpt sound in an immersive spatial environment. I am intrigued because XR, VR, everything tends to be a lot visual, and they're going to explore something with sound, which sounds exciting to me. So our presenters today are Kellyanne Van and Carl Moore. Take it away.
Hello everyone, thanks for the intro. I hope you're having a great SIGGRAPH, and we really appreciate you joining us here on the last day. We are going to be presenting our app, TimbreSpace. It's an XR music app. So yeah, let me just introduce a bit about us. I'm Kellyanne, this is Carl. We're both audio engineers, developers, and we are super passionate about building software because we are artists in our own lives and engineers, so we thought what better way to bring those two passions together than to build a company that is focused on making tools for people to also help them reach their creative potential and create new cool art and music. So yeah, that's me, artist. I love making experimental art, sound design, and abstract visual art. And I'll let Carl introduce himself.
Hello everybody, I'm an audio engineer as well, also a musician and visual artist, also a software engineer and game dev. I love sandbox games like Minecraft. Been playing them since I was 12 and really just love the genre of being able to like do whatever, create whatever you want. So yeah, that's kind of our background and like why we're building this app. So our main motivation here is how can we break away from the 2D screen paradigm that audio engineering and recording has been in for maybe about the last 40 or 50 years. Ever since DAWs were introduced, they've like completely revolutionized audio, and it's been incredible. However, a lot of them represent audio in about the same way, tracks and waveforms. So we think that there's more interesting ways to interact with audio. They can utilize their 3D space and touch and all these things that we like take for granted with acoustic music and with sound that we experience in the real world.
Yeah, and audio's always been a really cool space because it really adapts to whatever technologies we have available. Because now DAWs are the traditional thing to edit with, but they've only been around for the past like 40. Before that, it was tape. So there's definitely a lot of room to innovate with audio, and we want to be kind of on the frontier of pushing the boundaries to see what's next as far as integrating audio production into a new medium like XR. So that leads us to building TimbreSpace, the XR app. We really want to offer a new type of musical tool for people to use because as artists and just humans, we really need different novel ways of interacting with things to inspire our creativity and inspire new workflows.
So introducing TimbreSpace, this is our solution and the way of bringing music into your space, into the world. Here's a screenshot. Here's a little video of it in action. This is a little bit of an older build, but this is on the Vision Pro here. And you can see these are two different audio collections, and we have things connected up, and we can patch wires to each other. And yeah, it's a lot of fun. So what is it? It's a node-based audio patcher. It's a creative tool for artists, but it's also an audio analysis tool. Many DAWs have audio analysis capabilities in them, but TimbreSpace kind of puts this at the forefront. It's also just a playground for sound and physics, and you can just have a lot of fun with it. So it's kind of what you want it to be. Very configurable.
Yeah, and the XR app that we've been mentioning is a part of a bigger ecosystem that we're building. So there's the XR builds for Apple Vision Pro, and that's currently available in the Apple Store, but we're going to release our Quest version soon on the Quest Store. But we also have a web app and a music community where you can publish your sounds and share them with the community and have them accessible on the web app or the XR apps. And then we also are working a developer SDK that we'll have out soon, and a bunch of other backend tools for helping you create sample packs and other kinds of audio analysis and things like that. And this is kind of a slide to show some examples of the use cases of TimbreSpace. It's a really open-ended kind of app, like we've mentioned. It's kind of like a sandbox experience, a creative tool. So really whatever your intent is what you'll get out of it. So maybe if you're a musician, producer, composer, then you might want to just actually output songs or tracks or layers or just some kind of audio file that you can have standalone or integrate into other parts of your workflow. But if you're a performer, you can use it as a live tool with other people on stage or something like that. And then if you're a gamer, you might just want to approach it like an open world sandbox game experience. And this is also a helpful tool for programmers and researchers and educators where they can gain new insights and find new discoveries by interacting with data, visualization in an immersive, visceral way.
Yeah, so a little bit about Patcher languages. I'm sure a lot of you are familiar with maybe MaxMSP, Houdini, Touch Designer. These different paradigms basically kind of involve nodes, and then it's a graph. So you take the node and you connect it to another node, and that either like transmits data or it transmits events. And you can create these complex networks. And it's a great way to abstract logic, and it's a kind of alternative to programming the text. So, yeah, for instance, Touch Designer is a good example, and as well as, yeah, as I mentioned, Houdini, Pure Data. These are just great ways to kind of prototype. So, and then we also take some ideas from DAWs. If you look at Ableton Live, for instance, Ableton was able to kind of change the paradigm a little bit by adding really great tools for producers to create beats, and that kind of expanded the capabilities of multi-track recording workstations, and a lot of them follow suit after that. But I see Ableton as kind of like the leader in really great music tools for musicians, for producers. And then of course we have Minecraft Redstone. I love it. You can create like cool contraptions, and it's less serious. You can just kind of create whatever you want. Some people go to extremes and build a whole computer in Minecraft. It's pretty cool. So
yeah, we also are inspired by analog synthesizers. So we're showing here a modular synth rack at the bottom right, I guess, bottom left, whatever direction is for you all. And then a sequencer and an instrument called the Library 8, which is like a synth that has like all these cool touch capacitors. So the analog hardware synth world is really cool because it's a space where people go kind of crazy with like circuit bending and like aesthetic choices and naming conventions. It's just kind of like a wacky kind of world of instrument building where people really express uniqueness, which is something we're really excited to do with the XR app, because we have the chance to make these fantasy instruments and objects that could never exist currently in the real world, and we really want to take advantage of that rather than rebuilding things that already exist in today's world.
So a bit about background about this project. It began with work of my professor at American University, William Brent, who built the original TimbreSpace in Pure Data and Gem, which is a graphics library that kind of plugs into Pure Data. And what the original concept was is you take audio features such as MFCCs or like spectral centroid or kurtosis, like these different audio features, and then you plot them on two axes, and then you have a mouse. You can scroll around, and that mouse activates those sounds. It's pretty cool. You can explore these timbral gradients that really kind of like reveal more about like a corpus of sound, like collection of sounds and like how they're related to one another. Very fun to play with. So like what I did was I took that and built that into the Z-axis and built it into a VR app called TimbreSpace VR. Back in 2019, we took it to ICAD, did a demo there. It's an international conference of auditory display, and it was really cool. But I was in college, so I didn't really have enough time to finish this or make it into a whole product. So fast forward many years, finally have that chance. So how does it work? Well, we patch nodes together. We sample individual audio files rather than the original version where we just take a windows of a single file. We sequence events together, so any type of event, whether it's playing an audio file or triggering other things in the software, can be sequenced. We also mix all these output signals with effects and just with gain, and then we have signal analysis, which helps us plot the signals within the space so we can understand them.
Yeah, and we also have a bunch of new features coming soon. Well, the main new product we also have coming out is the Quest release, which we'll have out soon. And then in both versions of the Quest and the Apple Vision Pro, we are going to have more perimeter connections and OSC support, so you can send and receive OSC from other programs like Unity, Touch Designer, SuperPad, or whatever program supports OSC, and also more recording capabilities, so to record more precisely in the app, but also with external mics and external interfaces, and also mini games, so we can take advantage of the fun physics stuff that we have going on, and then also kind of make it more accessible to an audience that isn't as technical or music focused. Yeah, and then the last thing we'll show is just our website. If you want to check it out, we have the web app, which is a simple kind of visualization of the similar kind of audio analysis that we're showing in the XR app, but there's also the chance to upload music if you'd like, and to check out the sample packs that we've uploaded as well, and then also to sign up if you want updates for our new releases and things like that. We also have some documentations and a bunch of videos that kind of demo different use cases as well. But yeah, so that's about it for our presentation segment. We're gonna switch over now to the demo portion. We're gonna start off by showing the Vision Pro version of the app. Yeah, and we'll just need a second to start the streaming there.
Great, yeah, and just to mention, our Vision Pro app is currently what's available on the App Store for the Vision Pro. Like Colleen said, our Quest version is coming soon. We're super excited about that. So she's gonna get the stream set up here right now.
Okay.
So we're gonna just kind of start by just showing you some of the basics, and then we're gonna kind of create like a little session, maybe create a little beat, and then play around with physics.
Okay, so I think this is. Oh, okay, hold on. So this is. But can you drag it to the other? I think it needs to be dragged. Yeah, we're just gonna have to drag the screen really quickly. Okay,
No?
there we go.
Okay.
Cool.
Great. Okay, so Colleen here has a session open. These are two different audio sample collections right here. This is the way we have information represented, different audio samples, and as you can see, they're kind of clustered in different parts of the box, and the location of those clusters kind of indicates how those sounds, what they sound like. They're timbre. So we're getting a little bit of lag here on the stream.
Oh, it is. Okay.
Yeah.
Oh, okay. Sorry. Oh,
Should be
okay.
good.
Okay. Yeah. Just restart
Yeah.
this.
Let's just do a fresh start here.
Here, let me just.
Also, we're not hearing audio. So
Okay.
are you guessing the audio?
Yeah. Let me. Okay.
There we go.
There's
Okay.
audio. Okay.
Great. Okay, so you see here, this is a sample pack browser. This is the primary way that you would pull in samples in the TimbreSpace, and that's the way that you can spawn those boxes that you saw earlier. So Colleen is going to pull out one of these. Two harps. Just a bunch of different harp samples. So there's about 140 different samples of harps in here that Colleen collected. We're going to explore the timbral gradient.
Oh, okay. It's quite laggy.
Yeah, maybe there's an issue with the connection here.
Yeah. Well, that's okay.
Yeah. Okay. Well, we'll just try and continue here.
Yeah.
So yeah. So is
Okay.
there?
I think is it frozen a little bit?
Yeah.
Okay.
Do we have a lot of traffic on the Wi-Fi? I'll turn my connection off here.
it recast, maybe? Or maybe
have we done? Have there been Vision Pro screens here?
Okay, I'm just
Okay.
gonna try
Apologies.
one more time.
No,
And
attack
if
demo.
this-
Yeah.
Yeah, if this is too laggy, we can also just show some overview videos we have of the Vision Pro version, and then.
Yeah. We'll just we can just show a video of it
Oh, okay.
if that doesn't work. I believe the Quest version should work perfectly.
Did you turn off? Okay, so it's not connecting anymore. Let's see.
Okay. How about we just
Yeah,
let's
sorry,
scrap that
it's-
one for now.
We're having casting issues.
Yeah.
But we can show a video.
Hey, hi everyone. Just a request, could everyone go on airplane mode for a little bit just to make sure they get enough bandwidth for their demo?
Yeah, thanks. We really appreciate it.
Just for a few minutes and then we can be back.
Hopefully this will solve some of the bandwidth issues.
Should I just try again then?
Yeah, let's try it again.
Okay. For you all to read, so I'll kind of just talk through what's happening in the session. Oh,
All right.
okay. Yeah.
Where's the first Yeah.
Yeah.
Stream there. There we go. All right. Right. No problem. Okay, great. All right, so here we're in the main page. Looks the same as on the Vision Pro app, although we have some more features here on the Quest. So let's pull in a sample collection here. It's tubular bells. I'll let Colleen describe what's going on here.
Yeah, so this is just a sample collection with a few different types of instruments, tubular bells, vibraphone, and glockenspiel. So it's three distinct instruments, and you can see the clustering worked very well to load in the samples in their own section of the graph there. So we're using MFCC, or sorry, we're actually analyzing. We analyze the audio through a model called CLAB, contrastive learning audio pre-trained model, and then we're doing UMAP dimensional reduction to reduce the amount of information and get these really nice clusters. So that's what we're seeing here. Yeah, so with this wand tool, Carl's able to just kind of like sweep over and audition the sounds.
So you can really hear how the different clusters here really have different timbral characteristics. As Colleen mentioned, yes, we're using neural embeddings here to display like how things are related to each other, and we're using UMAP to reduce dimensionality. But we can also change the axes here. So this is this is the way that we actually change the data visualization, change the axes here. This is one of these inserts that we have on this collection. It's XYZ. I'll let you explain what's going on.
Yeah, so there's different, we're using a C# library called N-Waves to extract other audio features, like different MSCCs, and then also other features like contrast, or loudness, and things like this. And you can individually map each axis, and you can also do this for the color feature as well, for the HSD. And you can use HSD as well. That's an option. And then you can also change like how the sample scale to make the different sizes. And this wand tool is really great because in addition to just being able to audition sounds and use it kind of like a conductor wand, you can also use it as an arpeggiator. So the sounds within the radius of the tool will sequence in different ways according to how you have the parameters set.
We also have different physics modes here. So this is a spring that kind of feels nice to have things kind of spring around it, and then has a different interaction with the one here. We can also use the arpeggiator, which just makes us an automatic arpeggio. continues that constantly, and we can change some variables about how that arpeggiator comes up with that. I'm just going to turn this down a little bit. So, for instance, and you're seeing here I'm opening up these parameter menus, which is how we can tweak every single difference operator within the program. So I'm going to turn on evolve sequence, and maybe you can describe how that works.
Yeah, so there's different patterns you can add, like 4 on the floor, and things like this. And you can also change the note division to kind of determine like how the frequency of the note size that you're actually sequencing there. And you can also change the sequence length, the repetition amount. And this is just that sample pack menu again. The Quest versions we're really excited about because using controllers is so much easier than using eye tracking and hand controls with these really precise targets that are available in some of the smaller perimeter UIs we have. So this is just a drum sample pack he just loaded in. And you can also evolve the sequence, so that will just vary the sequence over time in different ways.
You can also demonstrate connections here. So just one of the core concepts here is we can manually create these connections. So here the arpeggiator is creating by itself. We can also manually create them. So we can create these kind of complex networks connections between the different nodes here. So we see with this first one, the subsequent ones continue. And the subsequent the others again. So this is a great way so we can audition different sequences of notes here. So I hit the grip trigger, I grab, and I pull to another note. But also, it's pretty arbitrary, so I can take a connection from here. I can also bring it into this other collection here. I'm just going to stop this, and then I can play on the video. So you see that they're connected together?
Yeah, the wires that are connecting all of these nodes to each other also have this red kind of pattern rendered to show the direction that the sequence is moving in. So it just kind of helps you see the signal flow because as you're seeing, even if you change like the XYZ axes, the wires will stay connected like this kind of web of sound. And it just kind of helps to visualize what direction everything's moving in.
Pull in the sample question here. So another component of this analysis here is that since we have this collection of sounds, and we want to mix them with another collection of sounds. So we can select this collection, which is indicated by this green box when we have this on the active selection, and then we can take another sample pack and we can say, I want to spawn that into the selected collection currently. So that's going to then rerun the analysis, and that's going to recluster everything so that we can see exactly how those samples relate. Just give it a second here. Unfortunately, I spawned it in with a little bit of physics here.
Yeah, I think it's just
We're still working on this build,
laggy,
so
but
we need a little bit of limitations about how many objects are called into the app, obviously. All right, forgive us for that there. Appreciate it. Okay. I'm going to demonstrate that again, but instead I'm not going to have physics turned on. The issue was I had a bunch of objects in there, and I turned on. I added the other ones, and then they collided, and those collisions kept creating infinitely more collisions, which I said, it's something we're going to work on here. So let's add harps to bubbles, and let's see how these sounds relate. Just going to run the analysis. Okay. Sounds like we have some kind of really good sondas there. locally serviced. Let's throw some other things in there. Let's do some percussives. We run the analysis. Rearrange the axes and see how other arrangements work. So like here, I can mouse over this and see what we got going, which is MFCC 1 on the Y, MFCC 6 on the X, and spectral sense right here on the Z. Cool. All right, what else should we show? I think we should show what really brings us into mixed reality, which is our more physics-based interactions. Here's our spawner gun. So this shoots little grains of sound. You can shoot them all around the stage here. So we've got a bunch of different claps here. This is really fun. So what's cool about everything in TimbreSpace is it's just kind of arbitrary. So you can take this, you can patch that into the gun. So every single time this note here is fired, it's going to shoot a ball. So you can start thinking about like complex things that you can create, complex different networks of actions. Like for instance, we can also take something into the XYZ. So if that note is triggered, it's going to reanalyze it and rearrange everything. You can also. So we also have the different physics modes here. As you see, the whole collection can become kind of free physics where all the nodes are floating around, but we can also have them constrained. Kind of just mix and match whichever way you want. I'm going to pull up the menu here, pull up the object browser. This is a way for us to spawn different types of nodes into the app. Maybe you can describe what different types of nodes we have.
Yeah, so we have trigger node, talk node, bubble player, physics panel. The trigger node is just kind of like a button extension. It's kind of like a little extension port where it extends the clickability and triggerability of the node. So instead of hitting the button directly on the back of the gun, you can just connect a trigger node and hit the back of the trigger instead. And you can do this, and you can connect the trigger arbitrarily to anything you want, just to extend like the functionality of whatever system you're trying to make.
We also have probability and delay on the trigger, so you can change those. So like if you want 20% chance of that trigger firing after this one, you can do that. So maybe some of the time here, it's going to start a new arpeggio, but it's always going to fire the gun because the probability on this is 100%. So you see, I've pressed it like 4 times, and it only fires out once out of that 4 times. So you can kind of start creating interesting graphs. Press the grip trigger, make a connection there. Change the XYZ coordinates. Cool. Let's pull in a clock node. Tell them about the clock node.
Yeah, so this is like a BPM generator, so it just sends out a pulse at whatever BPM you have set. It's by default set to 120 BPM, so it will just trigger whatever it's connected to activate based on the pulse that you set. And it's really fun to use with the other delays, like he was mentioning with the trigger node, or even the there's these little gray connectors that pop up between connections that also you can manipulate as well. So there's just all these layers of time manipulation that you can have to really complexify your sequence.
Okay. Let's talk about. We have the physics panel here, and you can start kind of creating these little environments out of different panels. Change the material. Make this concrete right here. And we have different physics interactions happening with this gun. We can kind of create all sorts of wacky like little things that create cascades of sound. You see those hit the get the screen up there because we meshed the entire thing.
Do you want to bring up the gravity well?
Oh, okay. So this is kind of our newest node here. And this just basically, it tracks everything around it. It's fun to play with physics like this. I'm a big fan of Kerbal Space Program. I don't know if anybody's played that, but I mean, it's a hugely popular game for some of you have. I love gravity. I love seeing interactive things. So we have these audio brains. I'm shooting out this gun. Some of them are orbiting around the gravity well here. You can see the amount of gravity, and then I'll shoot off. All right, so I'm going to clear up a session here so that we can get a more clean, maybe more musical session going on. That's a little bit chaotic, but
yeah, maybe just give a little sample. We're actually going to have to wrap up.
Oh, okay. Okay.
Yeah.
So yeah, let's just kind of create like a nice chill beat. I think I wrote drums. I think we'll do that. Spawn one of these in. And then let's take a look at what's yeah, let's see this. All right. Okay, so we're gonna start one of these algorithmic sequences. Pretty wacky and pretty experimental. It just depends on like what kinds of samples you pull in.
Yeah, we also have a bunch of effects. So this is like a filter that keeps affecting, and there's delay and reverb, and like distortion and chorus, and we'll add a bunch of other effects as well. And we eventually also want to be able to use other plugins and VSTs in the app also.
So this is our first arpeggiator here. It's very simple. It's just kind of a press of a button and it does it for you. But we're looking to add like more interesting tools that you can like really like dial in what the sequence that you want. You know, really using the spatial qualities of the XR. So that will probably be in our first Quest release. But for now, these are the three inserts that we have currently on these collections. When we take up the delay. Let's pull up the parameter UI for these effects here. Sync that to the clock. So this going here. Okay. You can do these kind of DJ like filter.
And with our improved perimeter connections that we're going to build and release as well, you'll be able to affect different. You'll be able to attach different perimeters to other perimeters instead of just attaching full nodes to each other. So then you can actually like do things like affecting the effects of just a certain set of the grains in a collection versus the whole entire box itself.
How are we doing on time?
I think, do we have about like 8 minutes left? Are we good? Okay, I think we can wrap it up. Sorry about that.
There we go. All right. Well, thank you everybody for checking out.
Yeah,
I really appreciate it.
oh yes, I was just gonna say, we'll have this out on the Quest store soon if anyone wants to check that out. Yeah, definitely just keep up with our website, and we'll be trying to post more also. If you want to connect with us, all of our info is on our website if you want to find us and talk more with us about it. We'll be here, so yeah, hope to connect with you all later on in this conference. And yeah, thank you again for coming by.
Thank you so much, Damian and Carl. I think we have time for a couple of questions. So does anyone have a question?
Maybe I should try to cast in the meantime.
Yeah.
Oh.
Hi.
Hi.
Thanks for the presentation. I was wondering how on the limits of each device in terms of performance are you with this application?
Yeah, it's a great question. My instinct was originally when I started building this that I would build with the most powerful device. The Vision Pro has the best processor and all that. So I thought it was going to be way more powerful. It turns out I'm very, very limited on the Vision Pro. And that's because of the developer tools. We built this in Unity Spatial, which is a translation layer between RealityKit and Unity. And it's extremely, I think it takes a lot of resources basically to create this like virtual representation of what's going on in RealityKit and Unity. And so we can do maybe half the number of nodes in Vision Pro that we can on the Quest. And obviously the Quest is a much lower powered device, but the actual APIs and tools that you have available, like for instance, we can actually just write shaders for the Quest. You can't for Polyspatial except for shader graphs. Make it a lot better to develop for the Quest also. It's just a more mature ecosystem. So yeah, the Quest can do about almost 2,000 individual audio samples, or about 1,500 all with physics enabled. The lag you saw when a bunch of things were together was caused by like a lot of things colliding in a small space. So those don't do well, but I'm working on optimizing those. Thanks. Yeah.
Quick question. Have you done any user experience research into the interface?
User experience, Richard.
Yeah, just wondering if you've done any user experience testing.
Yeah, so we tested with a lot of people. So with family, friends, just people at conferences, just to get people's viewpoints on like what seems to work well for them, what doesn't. Yeah, we're just kind of doing it manually. Like it's just me and Collyanne, so we don't really have any like formal system for UX training, or I mean for testing. But we would like to do more kind of formal assessment of that and like see how people react, or like what types of controls are more ideal.
Yeah, and we're still trying to figure out the best ways to get feedback. Like we've tried putting out submissions, like just forums and surveys, but we're still kind of like needing to figure out a better way to get immediate feedback. But we're also trying to connect. We're both from Seattle, so we're trying to connect with the local XR communities there to do more in-person events, because there's quite a bit of things happening there, and there's like a few places that people meet up to do XR stuff. So we're trying to take advantage of that community as well. But yeah, so far it's just been pretty informal, but we have been making an effort to get a big variety. Like we've been testing on a lot of children, elderly folks, and also just a lot of people who've never used XR at all. So that's been a really helpful thing. But yeah, still working on how to make that process a lot better and more efficient.
Yeah, it's interesting. Kids like immediately understand everything somehow. Like you don't even have to tell them. They just, even if it's like the wackiest interface, they can figure it out. So that gives me hope about the future generation and like who the target audience might be, as they grow up, users of Quest devices or headsets.
Did we have one more question?
Yeah.
Over here? Okay.
Yeah, the flow seems very nonlinear. I was kind of curious if you could talk about how you would go about like mixing down like an actual track for output. Can you speak to that?
Yeah, so we still are figuring out the best way to do this. Right now, we're actually still really refining the saving, because there's so many different things that we want to preserve in a session. Either like there's all of these parameters that can all be changed and saved, but then there's also all of like the files, and we don't really necessarily have traditional tracks, but they're all are a bunch of individual audio files in these sample collections, and then there's of course like the track that we can produce from creating a sequence. So we're still really working on it, but we are really inspired by, like we mentioned, Ableton and like the Ableton Live element, where there's this component of live looping. It's not just like linear track exporting and mixing, but it's also like being able to have kind of like multiple dimensions in each track at the same time, and then you have control over what you bounce down versus what you just want to play to hear, versus like if you're just exporting also information like MIDI or things like that. So there's just really a bunch of exporting options like in Ableton and like in any DAW. So we do want to be able to offer something comparable where you can get like a flat just like a simple audio file, maybe like a session, like that's where we mentioned we want to have more recording features. So if you're just doing like a session, maybe just recording all the audio output, but also having the ability to record like the automations that you're doing real time, so that you can go back to the session and reopen and see everything you've done to make that session happen. But yeah, that's kind of a rambling answer, but long story short, there's just a bunch of different ways that we want to implement this. But I think the main thing is giving options to people, because we don't want to create a tool that's limiting, especially when the output is one of the most important parts of this. Is we don't want to just make an experience where you have to just be in the headset. We actually want people to use it in their everyday life and to listen to it on other devices or use it in other parts of their workflow also. But yeah, we have a lot to figure out there, pretty much. Yeah.
Let's take one last question.
I got two small questions. One is the software sort of space aware? Like if I'm performing in a room compared to a big hall, does it take like reflections and reverb into account? And then second question, maybe related to the last one, is the final deliverables. What kind of format are their deliverables, or what kind of format are they in?
Okay, yeah. So to answer your first question, we mesh the environment on the Vision Pro. That's the strength of Vision Pro, is it meshes the environment live. So that's the way the space contributes to it. You see like things bounce off of it physically. You can kind of use your unique space to create these like sequences of actions, physics actions that cause sounds. So that's really how the sound currently affects the space. We don't have spatial audio yet, but that is something that we're interested in adding. So I don't know if that fully answers your question, but then I guess to answer your second question, sorry. So what was that question again? In a second.
What would I deliver, like once I want to?
So currently we just have our saved file format is just a JSON. So and like Colleen was saying, like we want to be able to export stems. So we also have our user-generated content system, so that people can like just share their sample packs through our system, and not have to like deal with the individual files. But we want to give people full control. So we'll also give them access to the JSON files. It's just very simple, saying like what types of nodes, what connections are connected to which ones, and like if they're in sequences, what sequences are they on when they're scheduled for.
Yeah, and this also gives us the ability to make more features in the future that can make the tool more collaborative, so you can share the sessions as well, so other people can open a session that you've shared, or even real-time collaboration at some point as well.
Yeah.
Okay, thank you so much. Thanks for your wonderful presentation.
Thank you.
Yeah, and I love how you all improvise and switch devices, so thank you for that too.
Yeah.